All right, hi guys. We are going to look at a review of writing equations, but also look at some situations where equations, when you write them, will end up being multi-step equations, where you might have to do some simplifying before you solve them. So these are a little bit more difficult than ones that we've written in the past. This is on page 4 in your multi-step equations packet. So page 4. It's called Writing Equations Review because we have written equations before. So we're going to write an equation to represent each situation, and then we'll show all our work to solve it algebraically. So the first one, I want to order tickets to a concert. The tickets cost $19.95 each, which actually that's a great deal for a concert. There is also a $2.50 handling charge for each ticket in my order. And then finally, there's a one-time shipping fee, a $3.95 shipping fee on the entire order, regardless of how many tickets I buy. And I want to know how many tickets could I buy if I had this much money, $183.55. So, looking at that situation, you guys know we always like to start with the total. We know we're trying to get at the end to $183.55. And I want to spend exactly that. Let's see what I can do. It doesn't say at least or at most, so let's make an equation here instead of an inequality. And what do I need to add to get to that order? I've got tickets. I've got this handling charge for each ticket. I've got this shipping fee. So there's a couple of ways we could do this. I could say, all right, tickets are $19.95 each. Do I know how many tickets I buy? No. So I could say $19.95 per ticket, $19.95 per ticket, so maybe times X or times T. That's going to go into my cost. But also there's this $2.50 handling charge for each ticket. So in addition to that, plus I've got to pay $2.50 per ticket again. So if it's per ticket, it's going to be multiplied by how many tickets I buy. Then there's a one-time $3.95 shipping and handling charge, or shipping fee, on there. Does that matter how many tickets I buy? No, that's not per ticket. That's just no matter what. I'm paying $3.95. That's our constant, regardless of the variable on there. So that is one way I could write that. Another way would be, well, how much is each ticket? Each one is $19.95 plus another $2.50. So I could have just added $19.95 and $2.50 together and then multiplied by my variable, my x. But either way, it's going to get us the same result because look at what we've got here. Here's our equation. Now in order to solve it, there's my equal sign. I've just got to simplify this left-hand side first, and I can actually just put these together. I'm going to combine the like terms because they both have the same variable on there so that we can just add them together. So I'm going to do $19.95 plus $2.50, and you can do this in your head. It would be like $20 plus $2.50, so $22.50, except minus 5 more cents. So it should be $22.45. We can just double check it in a calculator because we can use a calculator, so don't let that stop you. There we go, $22.45. So $22.45 really per ticket plus our shipping fee equals how much we are going to spend. So now it's just solving this algebraically. We've got to get rid of the adding, subtracting first, so we're going to subtract $3.95 from each side. And this goes bye-bye. 2245x equals, okay, bring the calculator in just to be sure here. 183.55 minus 395 gives us 1796. 179, not 17. That would have been a big drop. 179.6, which is really 179.60. So we took off 395. We're still at 179.60. To get the x by itself, we divide both sides by 2250, and that's still on my calendar, or on my calculator there. So divided by 2245, x equals exactly 8 what? $8. No, 8 tickets. That's what we were trying to find. How many tickets we could buy for that. So there's our method of being able to write an algebraic equation, combine like terms to simplify it, and then solve it algebraically. We're going to do one more where there's an equation that we would write where we would need to simplify before we solve. Why don't you go ahead and pause this, read the question, try and write an equation, and then go ahead and watch again and see how close you got. Alright, so going through it, I add 4 to a number, then multiply the whole amount by 3. Finally, I add 10 to that product. My result is 34. For this one, I'm just going to go word for word, and let's see what we can do to take these English words and put them into math symbols. I add 4 to a number. I add 4 to a number. Do I know the number? Nope, there's my x. So adding 4 to a number. Got that. Then I multiply the whole amount by 3. That whole amount, if I want to multiply it by 3, I'd have to put parentheses around it to show it's the whole thing. And multiplying by 3, I could put a times 3 at the end, or I'm also going to do a 3 times at the beginning, because I suspect that's going to help me in simplifying this later on. So I multiplied the whole thing by 3. Finally, I add 10 to that. So I take all of that and add 10 to it. So I can stick a plus 10 on the end there. And I got my adding 10. My result is 34, so it equals 34. There's my equation. So to simplify this guy, there's our equal sign. We just need to simplify the left-hand side, and that's going to mean getting rid of these parentheses, which means doing a distributive property. 3 times 4 is 12. 3 times x is 3x. And then we don't do 3 times 10 because the distributive property ends when the parenthesis ends. So it's just a plus 10 hanging out there for now. Bring everything down. And now I can combine some like terms over here. I don't have any other x's, but I can certainly put the constants together. 12 plus 10 is 22. Still plus a 3x equals 34. Now there's nothing else I can do to simplify over here. I can't make that 25x because they're not like terms. So I'm ready to solve it. What can I do on both sides to start getting the variable by itself? Take away that 22. 3x equals, and 34 minus 22 is going to give me 12. And then I can divide both sides by 3. That goes bye-bye, and you get that x equals 4. For what? Did we have a unit for this? No, it was just kind of a mystery number. So our x, our mystery number, just started out being 4. Now, for both of these, should we be plugging them back in at the end just to make sure they seem accurate? 4, if I put that in for x, what is 4 plus 4? 4 plus 4 is 8. That's 8 times 3, 24, plus 10, 34. Looking good. All right, so those are a couple of examples of writing equations that would then lead you to need to just simplify before you solve. All right, that's the end of this video.